Library catalog is one of the most important microservices in the entire IT system because it retrieves and stores fundamental information for the other microservice. The catalog is designed as a RESTful web server using Cherry Pie, and that is the list of all the possible services offered by the catalog. We can divide the service in 4 categories that use different HTTP methods. The first category is retrieve category, and that use the get method. The second one is the add service, and it uses the post method. The third one is the update service and use the put method. And the last one is the delete service and use the delete method of HTTP. Now I start the catalog Python script, and as it's possible to see, we have designed the catalog microservice using Cherry Pie. To see some example of request, I'm going to start all the sensor inside our library. And here we see the get method to retrieve the MQTT address, and we see a lot of post method to add the sensor information to our catalog.
Simulators have been created to emulate the behavior of the sensor. In the smart library we have 12 sensors distributed over 2 floors. For temperature, brightness and humidity, the structure is the same and the message is composed by the following keys. Each time we publish a message, the value is chosen randomly using the Gaussian distribution. For the sensor inside the shelves, in room 11 we publish value with different mean and standard deviation because they are inside a special environment. The door sensor is created in order to emulate the door of the shelves in floor 1, room 1. The structure of the message is the same as before, and we publish randomly if the door is open or closed. And as we can see, everything is working.
Controllers are for different microservices that use the MQTT protocols to interact with other microservices in the IoT system. They are both subscriber and publisher. In particular, the goal is to check values published by temperature sensor, humidity sensor, brightness sensor, and the door sensor. And if a value published by one of these sensors is out of the correct range, they send an alert to the library admin on the Telegram bot. Telegram bot is one of the microservices inside our IoT system. In particular, it simulates a mobile application for a final user. If a final user registers itself as admin, it can change the status of some actuators inside our library.
Now I'm going to simulate the use of Telegram bot as admin user. First, I launch the Python script related to controllers and actuators inside the library. Then I start a Python script related to the Telegram bot and register myself as admin user through the Telegram chat. Finally, I start the simulation of all the sensors inside the library. As it's possible to see, on Telegram chat appears many alert messages. As we have said, an admin user can change the status of some actuators inside the library. To do that operation, the user has to use the command change. And he can change temperature values, humidity values, or brightness values. For example, we choose brightness and we select the actuator's ID. And now we put it on or off.
Book Scanner is a simulator which acts like a librarian. We suppose our library has 3 librarians. Bookscanner is an MQTT publisher. It subscribes to the catalog and it updates its information in the catalog after a while. Books are taken from a file with your book information. Delicates, it's also an MQTT publisher which publishes information about very specific books which are considered delicate. They are stored in a specific room in a library. The message structure and the code structure are very similar to Bookscanner. People Simulator is a simulator which is also an MQTT publisher which publishes how many people are booked for the study room in our library. Here is Bookscanner running. You can see that it connects to the MQTT broker and then it registers on the catalog. On the catalog, it also updates its own information after a while. The message structure is a classic SNML structure where the value which is published are title, author, and code of each book. Here you can see both People Simulator and Delicates running. They are both MQTT publishers, so they both connect to the MQTT broker. Then they register themselves on the catalog, updating their own information after a while. It's worth mentioning that when their time has run out, they both delete themselves from the catalog just like Bookscanner.
The channel ThinkSpeak is created in order to store the book's information. This is the channel that we create using the API keys that ThinkSpeak give us. We can communicate with the channel and we store the book's info using these three fields. Field 1 where there is a title, author and code. This means the book's info. Field 2, the location of the book, in this case floor 0, room 1, shelf 3. And in field 3, the number of copies.
Message Reader is an MQTT subscriber which implements the following functions. It receives all the messages from all the sensors in a library and it sends them to room controller and shelf controller. After a certain amount of time, it also sends information regarding books to the database, which in our case is ThinkSpeak. Message Reader requires information from the catalog in order to know which MQTT broker is used, and it updates this information after a while. Send2TS is a RESTful service which is used to send information on our database, which is ThinkSpeak. It stores all the useful information for the database, so API keys and API read numbers. Send2TS is used to retrieve information from the database, order it, and then send it again once it's updated. Being Send2TS a service, it also registers on the catalog and it updates its own information after a while. Send2TS also exposes the URL used to retrieve data from the database. And People Exposer is another RESTful service which is used to expose the information about the bookings of the study room in our library. It is a service, so it is registered on the catalog and it updates its own information after a while. In Room Controller, we send requests to End People Exposer. Here you can see all the elements introduced so far working. On the top left corner you see the catalog, on the top right corner you see the N people exposure. On the bottom left corner you see send to TS, and on the bottom right corner you see message reader. You see that all of them register on the catalog, and then they update their information, or they require information from the catalog, and then they update that information.
Until now, we have seen only the Telegram functionalities that can be done by an admin user, but there is a functionalities that can be executed also by a normal library user. First, we start the Telegram Python script and register ourselves as library user through the Telegram chat. Second, we select the command search and we can type the entire title of the book we want to reserve or a part of it. As possible to see, the Telegram bot responds with an inline keyboard where we can select the title of the book to reserve. And now, the book is waiting for us.
Here you can see our Smart Library web page. On the top right corner you can see the web page working, and on the bottom right corner you can see the people catalog handler working. In order to use the web page you need to either log in or register. Since I'm already registered, I'm gonna log in. After logging in, you can either find a book or reserve a seat. In this case, I'm gonna first find a book. In order to search for the book, you can enter the title of the book or part of it. It's also case insensitive. And here are all the books that match the keywords entered for the searching. If you want to reserve one of these, you can click on reserve the book, and the book will be ready for you at the library. If you want to reserve a seat, you only have to click on the reserve a seat button. Here you can see that the seat is reserved and the total number of bookings is 2. Here you can see the code for the library. And here you can see the code for the user's catalog handler.